Welcome to Yalgaar Club's Python Programming and Data Science Fundamentals training program. Now, I hope you all have viewed the PowerPoint presentation I shared with you, and I hope you all have installed the Python notebook, that is Jupyter notebook, of course, on your respective devices. And I hope you have run your first program of printing something. Yeah. So in this course, we are not going to emphasize on Python programming in depth, as we are going to go for the path of data science foundations, and we need some part of Python programming and not like too much of it. So let's start it, and I hope you all have installed Jupyter notebook. It looks like this, and you can create Python notebook here. So let's start it. So the operators are some of the most vital parts of fundamentals of Python programming. What is an operator? So it's basically a symbol that tells a compiler or interpreter to perform certain operations. And as we know, Python is a interpreted language, so it basically tells the Python interpreter to perform certain operation. So the operations can be arithmetic operations such as addition, subtraction, the comparisons, if two operands are equal or not. There can be logical operations like ANDing, ORing. There are bitwise operators as well, operations I mean, and they consist of basically bitwise ANDing, bitwise ORing, XORing, etc. We'll see that. As well as there are some great operators used too much in Python. Those are called identity operators. And now let's see what are arithmetic operators. So the arithmetic operators can be classified as unary and binary operators. The unary operators consist of basically plus and minus, and those are used just for signs of an operand. So I'm talking about operands so many times. An operand is basically a variable or a constant, and I hope you know what a variable is. It's basically a storage unit, and of course you know a constant. It can be an integer, a floating point number, anything, any numerical value, right? Or even characters. So unary operators are used to specify the signs of any operand. So if we run this, we can see +2 shows you the positive, and if you specify a negative unary operator, you get the negative value of that particular operand. And there is binary operator. It's used to perform arithmetic operations between two operands. It can be two or more, but as we know, these are actually only for two operands. People confuse it a lot of times, and the chained operations are actually based on the binary operation. So binary operators consist of plus, minus, multiply, divide. And here is something interesting. Let's execute it and see. Now you can see here you got the 5 plus 6 is equal to 11, 7 into 2 is equal to 14, then 8 minus 10 is equal to minus 2, that's negative. And then you can see 10 by 2 is 5.0. So what does this mean? The division operation in Python always returns you a floating point value, no matter if you have any zeros after that decimal point. Okay, and let's see how to avoid these. For that, there are modulus and floor division operators. Modulus gives you the reminder, so 10% 4 is equal to 2, of course, right? And the floor division operator gives you the quotient of the division operation in form of an integer, the rounded off integer. So let's execute it, and you can see 10% 4 is 2, and 16 floor division 3 is 5. So 16 by 3 is around 5.1 or something like that, and you can see you got the integer value. Now, as in the programming languages, the modulus here returns reminder of the after the division, and the flow function returns quotient after the division. Yeah. Now, the exponentiation or squaring, cubing, etc., these operations are very easy as in Python. If you see C programming language or C++, they have this power function, or you have to multiply too many times to get to it, and often there is a problem with typecasting like double, float and all. You have to adjust it basically, even if C++ has advanced a bit on that. But Python is kind of most easy for this operation. So you just have to use this star star operator and you are done with the work. So your 9 raised to 2, that is 81, and here's this long number 5 raised to 25, and you can see you can even compute 5 raised to 25 so easily without specifying some extensive data type or creating some, because if you look out for C or C++, you have to specify a macro or have to do a lot of typecasting for that. Now let's see the next type of operators, that is comparison operators. The comparison operators return the Boolean values of a comparison. So I'll show you by directly executing this. So 9 is equal to 9. This is a statement, and this statement's truth value is returned, or say Boolean value is returned as you execute that statement. And it's really easy in Python. You don't have to write if else clause to return or print any value. You just have to specify this statement and you're done. So yes, 3 is more than equal to, greater than equal to operators. Now let's go to next set of code. This is really important aspect, that is comparing the integer and float values. Now you can see here 1500 is equal to 1499.99. This is something we are trying to do, and it should return false, right? Because after decimal there are only 2 points and it should surely return false. But as we go for higher values after decimal points, will it work? Let's see. And you can see here this is false, this is true. Why? Python, even if supports a really easy way for comparison of integer and float values, there is a max limit for precision. So if you go over that precision's max limit, you will get it as equal. So here 1500 is directly equal to 1499 point so many times 9s after that decimal point, right? And we can go. So here we can see that in Python we can compare the integer and floating point values easily. Observing the above examples, we can say that precision is very important in Python. When comparing float and integer values, the floating points considered are 12. Over here, if you see, now this is false, right? Here we have used 12 nines after the decimal points, and as soon as we extend it to 13 nines after that decimal point, we get this statement as true. So for this value, 12 is the maximum precision to be set, but you can't be sure about that precision for every value. Every value can have a different precision after the decimal point, after which it wouldn't work. So as I've specified over here, this is something of utter importance in Python. Now let's see for the next piece of code. You can see 2.2 plus 1.1 is equal to 3.3. This is something I have executed and it returned me false value. Why? So the values stored internally inside your CPU, and as they are performed by the processor, they are not precise. As I said before, there's a max precision limit after which only you can have values as equal. Now over here, you can read it over here, the 2.2 value, the floating point value, might be stored as 2.19999 and so on, or maybe it's 1.1 which is stored as 1.0999 and so on, and addition of these values won't get you a perfect 3.3. It would be a bit less than 3.3, and Python takes care of that level of precision. So how to avoid these things is something of utter importance. Now to avoid this, we use a function, an inbuilt function in Python called as absolute, ABS specified by, and if you see here, absolute of 2.2 plus 1.1 minus 3.3. But again, here's a twist. The absolute function also doesn't give you that precision. If you specify, or say if I take 2.1 plus 1.999, it might work for absolute function, but here the precision doesn't get lower. So you have to specify it neatly. Now if I execute this, I'll just get the difference between the absolute value calculated by the absolute function and between the value we expect it to be as we calculate mathematically. Now here's the difference. It's around 10 raised to minus 16. So this is the amount of precision that has been seen from the perspective of this Python programming language, and you can see how powerful it actually is. So here again you can see even the absolute function doesn't work if you just compare the values as absolute of 2.2 plus 1.1 and 3.3. Thus I hope you guys can share with me what's your perspective and have some discussions around it, and try to find an answer to how this happens as in Python programming, or why this happens. Okay, so let's move to the next type of operators, that is logical operators. So what are logical operators? Basically and, not, or, these are all logical operators. I hope you have a prior basic programming knowledge, so that you can easily understand these terms. So what is and logical operator? Basically, let's just search logical ANDing, and you can see if two values, only if two values are true, you will get the output as true, right? And otherwise it's just off, that is false. So that's how ANDing works. I hope you know this basic knowledge. So in Python programming, you can use logical operators to consider two or more statements. For example, over here 8 is smaller than 5, 7 is greater than 3, and you can combine the results of these, or say you can combine the Boolean values of these in form of the AND operation, logical ANDing, right? So you can see there's something wrong over here. 8 is smaller than 5, which is false, and thus you get false, while here both statements are true, right? You can see. Now next operator, that is ORing operator, and it's again what is there in a logical ORing. Basically, if you have at least one value as true, you get the output as true, right? So you can see 8 is smaller than 5, but 7 is greater than 3 is true, so you get it true. And then there's logical NOT, that is inversion, or as in electronics terms we call it inverter, right? So we take this statement, which is 1 is smaller than 10,000, which is true, right? And then invert it, that is I should get the output as false. Yeah, I'm getting it. Now we can also use the Boolean function to return true or false. As in Python, we can actually directly specify these statements and calculate as for simple calculations or simple programming, but not always are these values supposed to be returned this way. Whenever you use Python as in a really neat software or a better development process, you can't directly just specify the statements. So Boolean kind of ensures that your statement always returns just true or false, 0 or 1, right? So Boolean of 0 is false, Boolean of 1 is true, and you can again use the similar statements, similar logical ANDing, ORing, and return the Boolean value of it. And there is one other exception. I want you to find out about what is a none type in Python. I am telling this because I want you all to explore it in perspective of programming, because if you don't explore, you won't get more things to be known. And I would recommend you to try it out from the documentation of Python. Okay, so Boolean value of none in Python is false. Now one quick notice, why I'm telling you to do some exploration is because you get to know more knowledge as soon as you approach that particular site or search for it. For example, if I take for instance none value, as soon as you will open the documentation or any information related to none value, you will find more information or on how none works in if else conditionals or in for loops. There are some problems you might face, and none value is really important when you see with the data science perspective. As soon as you go further, there is a process called as data cleaning, which consists of removing these none values, or in the data science it's called NaN values as well. They are like pretty similar. Okay. Then you can also perform chained comparisons by directly using the comparison operators. And what you mean by this I've specified over here. So 8 is more than equal to 9, equal to 9.0. It basically means two statements taken into chain. So 9 is greater 9 is equal to 9.0 is calculated, and it is logically ended. It's logically ending with 8 is smaller than equal to 9 as a statement. So these are two different statements actually, but are or can be considered as in chain comparisons. Try this for yourself with more chaining. Why? Because as soon as you start chaining more, you will get some complex comparisons, and try to analyze it by calculating it on a paper. But mostly in programming terms, you should not use chain comparisons to a higher extent. Just for the competitive coding or just problem solving, this is a good method to use though. Now let's move on to the next type of operators, that is bitwise operators. So I hope that all of you know what bitwise operation is. If you don't, please go through some reference material on how they are performed. So basically what is done over here, 6, let's see this example. 6 is converted into its binary form, and then there's 13, it's again converted into its binary form, and then bit by bit there's any operation. It can be any. There's ANDing, ORing, XORing. Okay, when you consider two operands, if there's one operand, you can even consider negation. Let's execute this piece of code and you will find these values. Do try to do it on paper. I'm suggesting this because you get to know the excitement level of using these operators. Even if they seem small pieces of code, they are of utter importance as soon as you move on towards the statistical and data science perspective. And we can also perform bitwise ORing, bitwise negation, bitwise XORing. There's right shifting as well, so you have to specify the variable or operand and just use this right shift operator and specify the number of bits you want to right shift the value, and you get result. And there's a left shifting and you get these results. So please do compare it by doing the evaluation on paper. Now let's move on to the next type of operators, that is identity operator. Now what is identity operator basically? If you have some basic prior programming knowledge, you might know the concept of referencing. It is mostly used in object-oriented programming. So what referencing means is, whenever you store certain value in a variable and you create another variable and reference it to the first variable. So let's take for instance, there's variable A, there's variable B, and you store value 5 in A, and then you just reference A to B, reference B to A, then the variable B will have the value as the value of a. So for instance, let's say this piece of code, we have stored a is equal to 5. Let's make a b is equal to 5. There's id function in Python which looks out for the uh, kind of address. You can call it as an address if you know the concept of pointers in C or C++ or any other core programming language. And does it like, let's say it basically returns the address of the variable. And if you execute this, you can see a has the same address, b has the same address. Now why is this? Because of referencing. So a is a variable with the same value as of b, and b is the reference to a. Similarly, we have is operator as an identity operator. So 45 is 90. This must be false because both have different values, and of course they will not have same referencing. While if we see 9 is 9, it might return us true, right? What do you think? Let's see. Yeah, so it returns true. What if we store 9.0 in something, or let's say compare 9 and 9.0 using identity operators? We get this false. Why? Now there's a different storage unit for floating points and integer point, or the way they are stored is totally different, right? I want you to look into core reason for this and tell me why this happens. I won't discuss it now because the excitement of knowing this new concept in Python will run away, and this is something you won't find everywhere. Now let's go for C is equal to 5, D is equal to 6, and check the identities, and you can see both have different identities. Of course they must have, because they don't reference to same thing, right? Same value. Now you can see we have this precedence of operators, and the highest precedence is given to the unary arithmetic operators. So plus, minus, then there's negation. These are unary positive, unary negation, bitwise negation, and there is there's one new line left over here. Over that there's exponentiation, then over that there's multiplication, division, and so on till Boolean ORing. Okay, and I want you to try these out as well by chaining these operators together and trying the calculations by hand on paper. You might have one or two problems and trying the same in Python programming, right? You don't have to do much like write printf and all stuff. You just have to write the statement and you will get the values, right? This is Python.